In this video, we're going to review how to use primary trig ratios to solve right angle triangles. So a right angle triangle we know is a triangle that has a right angle as one of its three angles. In order to talk about each of the sides clearly, we give them names: opposite, hypotenuse, adjacent. So hypotenuse is the side that's across from the 90 degrees. Opposite and adjacent will change depending on what angle we're talking about. So this symbol, that means theta. So if I refer to the word theta, that's what I'm talking about. It's just a Greek letter named theta. So if theta is the angle that we're talking about, then the one that is across from that angle, that would be opposite. And the leftover one would be adjacent, or the one that's just beside it. So if up here was theta, so this was the angle we're talking about, then this guy here would be opposite and this guy would be adjacent. So hypotenuse is the same no matter what, and opposite and adjacent change depending on what the angle it is that we're talking about. Are we talking about this one or this one up here? Then we have our ratios. So our ratios are named sine, cos, and tan. If you can remember from grade 10, when mathematicians compared right angle triangles that had the same angle, so for example, let's say that this guy here was 30 degrees, and we have, here's a small triangle that has 30 degrees in it, and then here's another big triangle that has 30 degrees in it. So there's lots of different triangles that can have, right angle triangles that can have 30 degrees in it. But what they realized is when they took the ratios of the sides of each of those triangles, they were all the same. It didn't matter how big the triangle was, meaning that if we have 30 degrees in a triangle, if we were to take the opposite side over the hypotenuse side and divide them, the lengths, it will equal the same ratio as in another triangle that has 30 degrees. So the only thing you need to know from that is that the ratios of every single angle, each of the ratios, sine, cos, and tan, they're all programmed into our calculators. If you had no idea what I was talking about up there, but you remember SOHCAHTOA, that's the most important thing. So SOHCAHTOA is just a way for us to remember each of the ratios and what order they are. So S stands for sine. So sine of an angle is equal to the opposite side over the hypotenuse side. Cos of an angle is equal to adjacent over hypotenuse. And tan of an angle is opposite over adjacent. Just to make sure that your calculator is working, it must be on degrees. There's multiple ways to measure an angle, and we're going to work in degrees. So just pop this into your calculator and make sure you get the same thing. When you put in sine of 30 into the calculator, you should get a half, or 0.5. If you put in tan of 60 into the calculator, you should get approximately 1.73. And if you put tan of 89 in the calculator, you should get approximately 57.29. So what we just calculated up here were the ratios. This is the opposite side divided by the hypotenuse side of a triangle that has 60 degrees in it. That's what that's saying. So if we have the angle and we're trying to find the ratio, we just use sine, cos, or tan, just like we did here. But if we have the ratio and we need to find the angle, that's when we use sine inverse. So taking a look down here, I have the ratio, and instead I need to find the angle. And so what we're really doing is we're just solving for theta. We're getting theta by itself. And we want to undo sine. And what's the opposite of sine is sine inverse. That's what an inverse is. It undoes a function. It's the opposite of a function. So we're going to take the sine inverse of this ratio, 0.9397, and we're going to throw that into the calculator. And you should get approximately 70 degrees. Let's try the next one. So again, we have the ratio. We need to find the angle. So we got to get theta by itself. So we're going to apply the opposite operation to cos. We're going to apply the opposite operation to both sides. And when we apply cos inverse to both sides, the cos and the cos inverse will cancel out. That's why we're left with theta. So on the right side, we're just going to have cos inverse of 0.7431 and it's going to equal approximately 42 degrees. Okay, you can try C on your own. I think we get the hang of this. Let's try to solve for a missing side now. If in grade 10 you ever remember being confused to when you should use the sine ratio, the cos ratio, or the tan ratio, the surefire way to always know which one to use is to make a quick list of what you have, what you need, and then it's really easy to figure out what you should use. So here's an example. First of all, we've got a right angle triangle, which means we can use the trig ratio, sine, cos, or tan. We can only use those guys if there is a right angle triangle. So we've got a right angle triangle. What should we use, sine, cos, or tan? Here's the first thing that you should do. Label your sides really quickly. And by really quickly, I mean this quickly. Which one's the hypotenuse? The one across from the 90. So I'm just going to put H or hype, whatever you like. Which one's opposite? It's across from the angle that we have or the angle that we're talking about. So we've got this guy's our opposite. And then our leftover is adjacent. It should be super, super fast. And now for the list, make a list of what you have. What do we have? We have, what sides do I have? I have the hypotenuse. So I've got the hypotenuse. What else do I have? I have the angle. So I'm going to call it theta. Nothing else. But what do I need? Well, I don't need opposite. It doesn't ask me for that. I need adjacent. So we need adjacent. And when you do this list, always, 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 two side lengths will come up. So in this case, we have hypotenuse and adjacent. And whatever side lengths come up, that indicates which ratio to use. So if I just write out SOHCAHTOA, which ratio uses hypotenuse and adjacent? Sine uses opposite and hypotenuse. Cos uses adjacent and hypotenuse. There, this one. So we know that we're going to use cos. So therefore, use cos. If you get the right answer every single time, you're always able to figure out which ratio to use and you don't need the list, that's fine. But if you tend to mess it up, this quick list will literally get you the right answer every single time. So once you know which ratio to use, just write it out. And I purposefully made a mistake here. What is my mistake? Cos means a ratio, but a ratio for what angle? You always, 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 always have to put an angle there. So let's fill in what we have. We know the angle is 39. We know adjacent. We actually don't know adjacent, so we're going to put x instead. And hypotenuse is 7. So now we're just going to solve this equation. So an easy way to solve, we've got to get x by itself. How do you get rid of divided by 7? We're just going to multiply by 7. We're going to multiply by 7 on both sides. This is going to cancel out. And we've got x equals 7 times cos of 39. And it's going to be 5.44 units approximately. Let's try another one where we're finding a side length. So there's really two cases. This is the second case. Okay, so not sure what ratio to use? Label quickly. We've got this guy's hypotenuse. Across from the angle we're talking about, it's going to be opposite, so this one's adjacent. That's how fast this should be. And your list is we have, what do we have? We have opposite, we have the angle, we have the opposite. That's where I got this from. We have the angle, and we need adjacent again. Okay, always there should be two side lengths that come out of your list, opposite and adjacent. SOHCAHTOA, what uses opposite and adjacent? Sine is opposite and hypotenuse, cos is adjacent and hypotenuse, tan is opposite and adjacent. So here we go. So we are going to use tan. Okay, so start off with the formula for tan. So tan of an angle is equal to opposite over adjacent, and then just fill in what you know. So tan, do we know the angle? Yes, it's 40. Do we know what opposite is? What is opposite? Yes, it's 20. And then adjacent in this case is x. So now this is a little different than what we had over here. Just to compare, here x, here, x, the thing that we're looking for, is at the top. And here, x, the thing that we're looking for, is at the bottom. When it's at the top, it's really simple. We just got to get rid of the number that's in the way of getting it by itself. taking a look here, even if I were to move the 20, so that's a multiplying by 20, even if I were to divide by 20, I'd still be left with x at the bottom of a fraction. I'd be left with 1 over x. So what we really need to do is we need to get x to the top. There's multiple ways to do this, but I want to teach you cross multiplication if you've never been taught it before, because it's going to be a helpful tool in solving equations generally. So this trick, it's called cross multiplication. It can only be used in specific situations. It can only be used when you have two fractions on either side of an equal sign. If you have anything else, so this guy is a fraction, this first one, if I just put it over 1, by the way. So I've got two fractions with an equal sign in between. If there was like a plus 2 here, like if this said like plus 2, we cannot use it, okay? It literally has to look exactly like this, just two fractions on either side with an equal sign. And then what you can do is cross and multiply. So what we're going to do is we're going to go from the bottom of this fraction and multiply across here, and then do the exact same thing on the other side. Bottom of this fraction and multiply it across here. Here's what that looks like. So we do 1 times 20, 1 times 20. And that's going to be 20. So we're going to put it on this side. We went across and it stays there, so 20. And then we've got x times tan of 40, x times tan of 40. That's just going to be x times tan of 40. And now x is at the top of the fraction. So how do I get rid of a times tan 40? I'm just going to divide. We're going to divide by tan 40 on this side and divide by tan 40 on this side. And these two are going to cancel out, and we're left with x is equal to approximately 23.84 units. So those are the two tools that we need when you're solving for a side length with SOHCAHTOA. Sometimes we'll get to a situation where what we need is at the top of a fraction, and we're just going to get rid of whatever is dividing by multiplying. And sometimes what we need is at the bottom of a fraction, and that's when we're going to use cross multiplication. What if instead in a triangle we have to find a missing angle? Well, you're going to start it off the exact same way with labeling. So we've got our hypotenuse, that's across from the 90. Our opposite and adjacent, we're always going to label those depending on the angle that we're talking about. In this case, we're going to be talking about this angle. We don't have it, but that's a reference angle. So across from that one, that's going to be opposite. And then our leftover has to be adjacent. So a very quick list. We have the hypotenuse. What else do we have? We don't have the angle. We have the opposite side. And we need, in this case, we need the angle. We can just call it theta. So again, two sides came up in our list, hypotenuse and opposite. And if I write SOHCAHTOA out one more time, SOHCAHTOA, which ratio uses hypotenuse and opposite? Take a look at the first one. Sine uses opposite and hypotenuse. Boom, there it is. So in this case, we're using sine. So let's write out sine and fill it in, see what to do. So sine of an angle is equal to opposite over hypotenuse. Sine is not a number. Sine is a ratio, and so we need a reference angle to make it a number. So it has to be sine of something. Okay, so sine. Do we know the angle? No, we do not. So we're just going to write theta equals. Do we know what the opposite side is? Yes, it's 39, and hypotenuse is 44. So don't divide this just yet. We're trying to use the calculator only one time so that we get the most exact answer as possible. I've got to get theta by itself, so I've got to get rid of sine. So we practiced this already. What is the opposite of sine? Sine inverse. Same as cos, opposite is going to be cos inverse. So what we're really doing is we're going to apply sine inverse on both sides, and the sine inverse and the sine is going to cancel out. So that's why we have no theta. If you want to think about it like we're just moving sine onto the other side and it becomes the opposite, that's fine too. So we're going to take sine inverse. So this is one of those examples where we have the ratio and we need the angle, just like what we did on the other page. So we're going to throw that into the calculator. And we get an answer of 62.42 degrees approximately.